Can you all hear me well? Hi everyone. Hi everyone. My name is Maggie Wang Yu Yang. I'm from UCL. Today I'll be presenting our multi-level latent class analysis of an OECD survey on environmental behaviors and policy support, together with my colleague Amy Roger from University of Edinburgh. So BR UK, Behaviour Research UK, is a research consortium funded by the UK Research and Innovation, UKRI, via the Economic and Social Research Council, ESRC. The consortium serves as a leadership hub to build national capability for behavior research in the UK. Our mission is to conduct interdisciplinary behavior research to contribute to addressing societal challenges. For this presentation, I will walk you through the background, the challenges we are facing, and then our study processes. After that, I'll present the first part of the results, the individual level findings, and then I will hand over to Amy to cover the rest of the findings together with takeaways for research and policy. Now we are all facing an imminent climate crisis, where energy, transport, and food sectors are the major contributors. To address this, countries often look across internationally to see what works in other countries and then try to apply the same lessons to their own regional or national context. But this could mean another challenge. Policies might not work well when transferred between the borders. And this might be attributed to population heterogeneity, which means different groups might behave differently in their everyday life and respond differently to environmental policies. For example, carbon tax worked in some places, but it might have led to the social unrest, such as the Yellow Vest protest in France. So our questions are, what environmental behavioral patterns exist, and who and where are they? How do they relate to policy support? What does it mean for policy transfer across countries and regions? We analyzed a secondary data set, as Sam have introduced a little bit. So the data set is the 2022 OECD EPIC survey with over 17,000 respondents across 9 countries, including US, Canada, UK, Israel, and several EU countries, consisting of 61 regions. The survey measured environmental behaviors in energy, transport, food sectors mainly, and then also assessed their support for environmental policies in these sectors. What we did is to use multi-level latent class analysis to identify population segments with distinct behavioral patterns and map them regionally to observe the within and between country variations. Let me briefly show you our analytical approach across the regions and sectors. Our study focuses on the 3 sectors covered in the EPIC survey: energy, transport, and food. From left to right, you can see that first we identified population segments in each sector using LCA, the individual level latent class analysis, to find the natural groupings of populations based on their similar behaviors. And then we map where these segments exist using MLCA, the multi-level latent class analysis, showing the geographic patterns across the 61 regions. For example, by regions, we meant something like UK regions would include Greater London, Scotland, East Anglia, etc. And we also conducted further analysis on the right-hand side. So on the top path, we tested if demographics predict segments and if segments predict policy support. At the bottom right, we examined if the segments are associated with one another across the sectors. In other words, can someone be sustainable or unsustainable in multiple sectors? Since our audience has a particular interest in energy, so throughout the talk, we are going to show a lot of our results from the energy sector. but we will also discuss related results from transport and food as we go so that we can give you the whole picture. We used 4 indicators, behavioral indicators, to identify the energy segments, which are selected and finalized based on established literature and statistical criteria. The first indicator we selected was the smart meter adoption, which means whether the participants have actively chosen to install a smart meter in their home, not just a passive acceptance. And secondly, energy saving behavior. How often did the participant engage with daily actions like turning off lights, minimizing heating or cooling, and hot water use? And the third one is the efficiency installation behavior, whether they had major investments in their home, including solar panels, heat pumps, insulation, and other highly efficient appliances. And the fourth one we have is the electricity bill with 3 categories: high, low, or unknown. You can see that these indicators capture different dimensions of energy behaviors, from daily habits to major investments. For the other sectors, namely transport and food, we have similar selections of behavioral indicators for the segmentation, which are all binary. So our segmentation analysis identified altogether 4 distinct segments based on the just mentioned behavioral indicators. So these segments reflect the different probabilities of engaging in each of the 4 energy behaviors that I just introduced. So we use the different shades of color to represent the level of sustainability of these segments. Darker here means less sustainable, and lighter color means more sustainable segments. So in the energy case, 12% are disengaged energy users. Their defining features are having no smart meter, no energy efficiency installations, and they had minimal energy saving behaviors. And interestingly, 66%, the majority, are actually energy investors, the largest group who have made efficiency installations and likely to often practice energy saving behaviors, but crucially lacked smart meters. And then we have 2 groups of 11%, the first one being energy conservers. So they are strong on energy saving behaviors and are likely to have efficiency installations, achieving low bills, but they also lack smart meters. And the final one, 11%, are actually the most sustainable group, which we call engaged energy users. So they are the only group with almost 100% likelihood to have smart meters, plus all the other sustainable behaviors. So altogether, these two plus together would be 78% who fall into the 2 least sustainable segments. What about transport and food? So we apply the same segmentation approach to these 2 sectors. And for food, you can see that on the left-hand side, we examined meat consumption patterns and then sustainable purchasing behaviors, such as buying in-season product and minimally packaged food products. And this reviewed 4 distinct segments as shown in this donut chart. So the darker brown, again, means less sustainable segments who frequently ate meat and had minimal sustainable purchasing behaviors. And then for transport here, we analyzed the primary daily transport mode and then their household car use, as well as the long-distance high-emission trips. And this resulted in 5 segments. And the darker green here represent the car-dependent segments. So as a summary of the individual level segmentation, we see this sobering reality across all sectors. Just to recap, energy, in the energy case, 78% fall into the least sustainable segments, with 12% disengaged energy users who have very little engagement whatsoever. And then 66% energy investors who invest in efficiency but lacked smart meters. And in the case of transport, actually 61% are the auto travelers who are completely car dependent. And then we have another 17% who are active and auto travelers who are still very much car reliant. And then in terms of food, we have 51% non-sustainable food consumers and purchasers. They frequently ate meat and had minimal sustainable purchasing behaviors. And 24% of sustainable purchasers who also frequently ate meat. You can see that this pattern holds actually across all 9 countries in the study and emphasizes the massive scale of behavior change required globally. So with the individual level segmentations, we further tested whether social demographics can predict segment membership. And here again, we focus on the result of the energy sector. So to do this, we added the 7 social demographic variables as a covariate into our analysis. And the reference group we used, remember we had 4 energy groups, segments. So the reference group is the least sustainable segment, which is called the disengaged energy users. So the result is sex showed no significant effect on any energy segment membership. And income actually were very inconsistent in the effect across the segments with no clear pattern. And in terms of age, those who are aged 18 and between 18 and 24 were actually more likely to be disengaged energy users than the older age groups. Having children actually showed particularly mixed effects. What we meant by that is that so the parents might be most likely to be energy conservers, followed by disengaged energy users, then energy investors, and are least likely to be engaged energy users. So this is a very contradictory and confusing pattern. And living in suburban areas only predicted being a energy conserver. Finally, education and employment had very little meaningful association with any segments. However, these weak patterns actually do not hold in the case of transport or food. An example is that in transport, those who aged 35 or above actually tend to be more auto travelers, which is actually the opposite of the energy case, where the older age tend to be more sustainable. And then in the case of food, women are less likely to eat meat frequently, but here gender, sex show no significant effect in energy and also in transport as well. So overall, no social demographics seem to work consistently across all 3 sectors. And what this means is that social demographics might not be a reliable or consistent predictor for environmental behaviors. And what about policy support? How do the segments predict support for environmental policies? Based on our linear regression analysis, we found that sustainable segments consistently show higher policy support, though the differences are quite small. Here again, we are looking at the energy segments. So again, we use the disengaged energy users as the reference group, and they overall gave the lowest support for all the 3 energy policies. So the numbers on the colored tiles are the mean, the average policy support level for this reference group. And the numbers on the right plots, the 3 plots here, 3 columns, are the effect sizes or the Cohen's d, which is the standardized difference measure of how different a particular group is compared to the reference group in their policy support. So specifically, a 0.5 is a medium difference, a threshold for the medium difference, and then a 0.2 is a threshold for a small difference. So all the 3 sustainable segments show higher support for the three energy policies than the reference group, as indicated by the positive effect sizes above the 0 vertical reference line here. And so the participants actually were asked to rate between 1 to 5 for the particular policy in terms of their support. So energy subsidies for this policy, energy subsidies actually get a 3.6 out of 5 from disengaged energy users, while engaged energy users are relatively higher, almost getting to 0.5, and also further away from the vertical line, and also compared to the other two relatively less sustainable energy groups. Actually, similar patterns were found in the transport and food sectors. So for instance, auto travelers, the least sustainable transport group that I just talked about, who are mostly car dependent, they show the lowest support for the transport policy, such as carbon emissions tax. And now I'm going to hand over to Amy to discuss the cross-sector and cross-region behavioral patterns and what our study means for research and policy. Oops.
Could you put it back into presenter mode, Maggie, please? Thank you. Perfect. So next, I'm going to discuss the association between being a member of a specific segment in one sector and how this relates to being a member of a segment in another sector. And to give you the general trend to begin with, what we found was that membership in the least sustainable segment in one sector meant you were very likely to be in the least sustainable segment in another. So what does this mean in terms of examples? Well, disengaged energy users were very likely to also be non-sustainable consumers and purchasers. And non-sustainable consumers and purchasers were also very likely to be auto travelers. And the reason why this is an interesting finding that we might want to dig into more is that all of these segments, the examples here on the screen, are characterized, as Maggie suggested, by a very high likelihood of engaging in behaviors that policies are trying to reduce, such as car dependence or frequent meat consumption, as well as a low likelihood of engaging in behaviors policies trying to promote, like energy conservation. And so we see this kind of association between unsustainable behaviors across sectors, but it is important to caveat that this wasn't always the case. So, for example, disengaged energy users weren't always likely to be auto travelers. On the flip side of this, when we think about the relationship between sustainable segments, what we found is that if you were in the most sustainable segment in one sector, you were likely to be in a segment in another sector that had some likelihood of performing sustainable behaviors. For example, if you were a sustainable consumer and purchaser, so this the most sustainable segment of food, you weren't likely to be an engaged energy user, which is the most sustainable energy segment, but you were likely to be an energy conserver, which is the second most sustainable class. And what these kind of correlational analyses suggest is that there does seem to be a link between sustainable and unsustainable behaviors across sectors, aligning with other research that's been done around behavioral spillover across these domains. And this is important because it kind of brings up this issue of the fact that research and policy tend to look at these behaviors and these sectors within silos. Next slide. But now that we've covered all of the individual segment results, so we've identified what segments exist with different behavioral patterns, how socio-demographics might predict these, what are the differences they have in policy support, how do the segments relate across sectors. We want to take a step back and think about how are these segments distributed across different regions in the OECD countries that were included in the survey. So when Maggie showed you those charts for each sector with the different percentages of participants that belonged to each segment, this was for the sample as a whole. And what we wanted to do with the second level of our analysis was think about how does this distribution differ across regions. And so what the model did, in hopefully simple terms, is group regions with similar distributions of population segments together. And by regions, again, we're referring to, for example, different provinces within Canada, different areas of England and the devolved nations within the UK. And what we found, the first kind of key takeaway of this analysis, is that national context matters. So regions tended to be grouped geographically based on country borders, meaning that all regions within a country were grouped together, showing very similar distributions of these population segments across the board. And hopefully we're going to illustrate what I've just overviewed there with a key case study example within the energy sector, where we look to understand the differences in the proportions of engaged energy users that we found through our results. So if you have a look here at region group D, what we have is a very high percentage of engaged energy users, around 30%. And this group comprised of regions, all of the regions of a lot of European countries like the UK, France, and the Netherlands. And this is interesting because a key indicator of being an engaged energy user, one of them, was having a smart meter. And what we find is that European countries exist within a context, whereas there's a very clear EU policy strategy around smart metering, and evaluations of policy and smart metering infrastructure across European countries shows that these countries in this region, which have a very high level of engaged energy users, have invested and implemented a lot of infrastructure to support smart metering rollout. To further this point, if we look at energy region group A, this was regions that grouped together with a very different pattern. Notably, there was no engaged energy users within this region, and all of regions within Belgium fell into this region group A. And this is interesting because if we go back to those evaluations of kind of EU smart metering policy and infrastructure, Belgium, close to the time of this survey, had set no targets around smart metering, and there was very limited evidence around implementation of infrastructure to promote rollouts. However, while national context is important to consider, our results also show that regional contexts matter, because there were clear within-country differences at times where you have some regions that outperformed or underperformed their national context, ending up in a different region group. And so to illustrate this, we're going to stay with this engaged energy users case study, but think about Canada. And if we look at this energy region group D again, where we have this really high proportion of engaged energy users, where we saw a lot of European countries fall into, British Columbia within Canada also falls into this region, in comparison to all of the other regions in Canada, which fall into energy region group B, which has a much higher proportion of disengaged energy users and a much smaller proportion of engaged. And what we look at is Canada do also have a national strategy around smart grids and evaluation work looking at the implementation of this. And British Columbia has evidenced more advanced smart metering rollout infrastructure than other provinces. Interestingly, no, that wasn't the case for all provinces. So we do see provinces like Alberta, for example, that fall into this lesser performing region group. And we denote this to context, kind of encompassing quite a lot of factors. So I focused a lot here on policy and infrastructure in how we triangulated evidence to support why these differences might exist. But this can also extend to other really important contextual factors that we know shape behavior, things like culture and social norms, that may exist within a certain location. And there is some evidence within the research literature that British Columbia, in comparison to other provinces, can have higher support and acceptance or understanding around kind of environmental behaviors and also environmental policy. But we've given you a lot of details between the two of us. So now we want to take a step back and think about what this means in terms of the limitations of this research, future directions we should be taking off the back of this, as well as the policy implications. And there are a few things that we want to highlight, first of all, in terms of limitations. So it's really important to note that these segments, population segments with different behavioral patterns, that behavior was based on self-report measures. And we know from prior work that self-report measures of sustainable and pro-environmental behaviors don't often correlate very reliably with more objective measures. So there's definitely could provide some error into how we're defining these segments based on their behavior. This was a cross-sectional design, so we are presenting segments and regional distributions that exist at a specific point in time for a specific sample in a very specific set of OECD countries. And we know from more longitudinal work using these types of approaches that the way segments are made up can change over time, or people's membership within segments can change over time. The distribution of segments across regions could change over time. So it's really important to note that this is a particular snapshot. As well as when we're thinking about that relationship between the different sectors, so that kind of, if you're unsustainable in one sector, what's this relationship between being sustainable or unsustainable in another? We can't look at that causal relationship, which a lot of the behavioural spillover literature tries to look at. But we do find correlational evidence that aligns with that idea that unsustainable behaviours cluster together. Another kind of interesting issue is around modelling constraints. So when we presented our explanation of potential reasons for the regional differences in the distribution of these segments, there actually is capacity within this modelling approach to quantify indicators of what we might expect. So being able to quantify differences in policy or infrastructure or just other features of context to predict more formally why these differences might occur. But it's really important then that these regions map logically onto potential infrastructure or policy borders and things like that. So we didn't do that in the current study, but it is an important consideration, especially when we start thinking about future directions. Things like, how do we track how these trends might change over time? How do we potentially build on research on self-report measures and try and get a better understanding of segmentation using more objective measures? With things, especially with the advent of smart data research, where we see things like Smart Data Research UK, which have big kind of data sets around behaviour based on digital technologies related to the environment. So just kind of thinking ahead of this, it does seem to be quite an informative method, but how can we continue to build off of the work that's been done in these really good surveys that have already been developed? And then finally, thinking about the policy implications. Kind of key policy implications that we want to communicate today. The first one's around tailored approaches. So this idea that policy should go beyond treating the population as homogenous, as being all of the same, and start to think about who needs what within their population and where they are. Because what our analysis does show is that there is this non-sustainable majority that really do need policy interventions that effectively promote behaviour change. But we do see still a good amount of people that are performing the behaviours that policy is either trying to promote or not engaging in the behaviours that they're trying to reduce. And so therefore there is also a need for policy that thinks interventions and behavioural interventions that think about maintenance and how do you keep these segments on that trajectory. Another important point is around cross-sector coordination. So we do find additional evidence that sustainable and unsustainable behaviours cluster together respectively. And often these problems are attempted to be dealt with in silos, but there's some we're not the first to shout for better coordination across these sectors, and there's definitely work looking at nexus research, which takes the intersection of these different types of problems that sit within these sectors and think about what are the co-benefits of policies in one sector or a policy targeting multiple sectors, or what are the unintended consequences of a policy that might produce progress in one sector but unintendedly hold back another. And then the final thing that we want to highlight is just the framework, the approach to the analysis that we took, we think can really help inform that idea that policy learning and transfer across regional or national contexts is a really important part of how we're trying to move forward with climate research, climate change research and policy. And a lot of the time that happens through informal networks or through collaborations like the OECD, trying to facilitate understanding this is working well over here and what can we learn from it. But this just provides another strategy, just another tool in the toolbox, you can think of it, as a way to identify where there might be opportunities, either to learn within your own country from regions that are outperforming or maybe underperforming, or across national borders to see what countries on a whole are overperforming or underperforming on the average. And the way we see that framework working is just kind of going through that analysis process that we've just walked you through. So identifying great surveys like this EPIC survey, where there is indicators of behaviour and we might be able to better understand segmentation in the population, as well as regional level data so that we can understand how this differs across different locations. Your step 3 then is about thinking of that mapping on the tailored approaches that I just discussed, that not all segments will need the same policy intervention based on our policy support findings. Not all segments will be as accepting of certain policy interventions. So there's work there around communications, not just interventions. Step 4 around regional comparison, we obviously did those case studies, triangulating evidence post hoc, but also thinking about, can we add in certain indicators that we think might be important predictors of regional differences? And then we were thinking for that future research piece, it's really important to actually go beyond what we've done in the current study and think about where we do identify those regions or nations that we think we can learn from, where there is evidence that there is policy and infrastructure differences. What's the strategy to developing and implementing that in a new context? How do we validate that? How do we evaluate it? Is really important and something that we think would be a key point of this framework that kind of goes beyond the scope of the current study we did. I'm aware we gave you a lot, so I'll be happy to hear your questions in a second, but I just want to thank all the contributors, collaborators at BRUK, as well as user TCP for making data sets like this available for these types of analysis. And if you want to read more about our work based on this, you can find out more in our preprint. Thank you very much.